Grüezi YouTubers, here is the guy with a Swiss accent, with a new episode around sensors and microcontrollers. In video number 140 we hacked the new IKEA Tradfri smart lighting system, using the remote control as a basis. It worked, but had some major disadvantages. So I decided to change the strategy and use the IKEA gateway instead of the remote control. This should have some advantages. But if you want to hack the gateway, you quickly discover that it uses COAP, the second important IoT protocol. Today we will dig a little into this protocol and compare it with our well-known MQTT protocol. At the end, we will understand the relevance of the COAP protocol and where it is used. We will have an idea about the concept of RESTful APIs I already used in video number 27. We will understand the basic differences between COAP and MQTT. We are able to use COAP on our beloved ESP8266. We will learn a little on how to spy networks using Wireshark. And of course, we will be prepared to hack the IKEA gateway in the next video. But before we can start, I want to show all my Swedish viewers the reason why I thought Tradfri is Danish. If you enter Tradfri into Google Translate, it detects automatically Danish language. If you force it to Swedish, it does not translate. I apologize for any inconveniences. By the way, this mistake created the biggest discussion on this channel so far. But let's continue with technology. COAP, or Constrained Application Protocol, has its roots in the well-known HTTP protocol, which is used for most of our web pages. But it is adapted to the needs and restrictions of small devices. So, it is somehow a competitor to MQTT. It uses the concept of RESTful APIs. This concept is widely used for web services. Most of the websites offer such an API interface. RESTful calls are easily recognizable if you look at the URL in your browser. It usually starts with an address of the web service, some additional stuff which defines the particular service you want to use, and a question mark with some more stuff. This example searches Twitter for all tweets from my user. Very important is that with this concept, services can offer 4 different methods. Read information with the get command, update information with put, create new information using post, and even delete information with the method delete. So this is a very versatile concept for web services. And what is now COAP? COAP is a protocol which can transport RESTful calls over thin networks. And it is also adapted to the small resources of IoT devices. This is why it uses the more efficient UDP and not, like HTTP, the TCP protocol. And it only needs small memories and slow processors for the nodes. Exactly like MQTT. But this is the only commonality, as we will see. Let's first look at a typical network. We all know the concept of MQTT with one broker and many nodes. There is no direct connection from node to node. All communication is done via the broker. With COAP, the communication goes directly from a client to a server. No intermediate is necessary. Exactly like web services. One node also can connect to many different servers. So somehow the node is the center of this network, not the broker. MQTT uses a publish and subscribe concept. As soon as the broker gets a message from a node, it sends it to the network. Theoretically, all connected nodes can get all messages. Because each node can subscribe to interesting topics, it only gets the messages concerning the topics it subscribed. MQTT only transfers information. It has no concept to alter information on the opposite node defined into the standard. If you want to change information, you have to define your own messages to emulate get, put, post, or delete. On the other hand, MQTT has a concept of quality of service and store and forward implemented in the protocol, which is superior to COAP because it also works if one node or the connection to a node is partially down. This is particularly important if you want to sleep your nodes for a certain time and only connect to the broker at defined times. It is also possible to create such a concept using COAP, but you have to program it yourself. It is not part of the protocol definition, and you do not have a broker which is always on if you do not build it yourself. At least this is what I understood so far. So summarized, MQTT is very good at transferring data or commands from and to remote devices over unstable connections because of its unique QoS and store and forward concept. With MQTT, the broker is the center of the network. COAP is very well suited for work with service over relatively stable connections. Nodes can connect to many different servers at the same time and can execute commands. Both protocols are very well suited for low volume networks and for low power devices. Both protocols are heavily used in IoT applications. Both protocols can use secure lines. With COAP, the preferred cryptographic method is DTLS. So let's play a little with COAP. In principle, it is very easy to use it. Just replace the HTTP with COAP. However, if we do that in Chrome, we do not get the expected effect because Chrome cannot deal with this protocol. If we use Firefox with an extension called Copper, we get an answer. First, we see that COAP runs on port 5683. Then we see that this server exposes a service called LED. This mechanism of displaying all available services is called discovery. So the client does not need to know exactly which services are offered by the server. This is a nice feature we will use later with our IKEA setup. But where does this message come from? People who know me can guess. Of course, it comes from the COAP server running on an ESP8266. And this ESP also has an LED. First, we can request the status of the LED by issuing a GET command for the LED service. We see in the incoming message that the LED is on. Now we want to switch the LED off by issuing a PUT0 command. And really, it switches the LED off. We also can check its new status. It is 0. So this whole thing seems to work. At the beginning of this episode, I mentioned that COAP protocol works on constrained networks. Let's check if this is true and if the messages are really short. To get this information, we can use Wireshark on our PC or on the Raspberry Pi. It is open source and helps with many hacking or network problems. We trigger to the UDP port 5683, which is the port used by COAP. And we see the messages flowing through the network. Their length is usually around 50 to 100 bytes. The longer ones are the discover messages, which are not often used. So the promise is kept. The packets are really small, but I think they are a little bigger than with MQTT. How did I build the ESP8266 COAP server? Simple. I just installed this library and used the example provided. And of course, there is also an example for a COAP client available. And with this client example file, I am even able to connect to my alma mater, the Swiss Technical University in Zurich, with my tiny ESP8266. They run one of the COAP test servers. How cool is that? If we discover all services offered by this test server, we see the possibilities of COAP, which are huge, much bigger than with MQTT. But because I do not understand all of them, I will stop here. Now we have to focus on one COAP feature, which will be important for our IKEA hack: encryption. As with HTTP and its secure sister HTTPS, COAP has also a secure sister, COAP-S. If we replace COAP with COAP-S, we see that Firefox and Copper cannot handle this protocol. Because IKEA correctly uses the secure version of the protocol, we still have to go a long way till we are able to get these damn lamps switching on and off. But you can be sure we will succeed. For today, we built a basis for our next step. We looked at the relevance of the COAP protocol as the second important IoT protocol together with MQTT. We learned the meaning of RESTful APIs and played with get and put methods. COAP is very well suited for client-server applications over stable networks. MQTT, because of its built-in QoS levels, is well suited for applications with unreliable networks or where the nodes are in deep sleep for a long time. The broker can store the messages as long as the node is not available. We found a library to use our ESP8266 as a COAP server and also as a COAP client, and we were able to test it in both scenarios. Wireshark helped us to trace network traffic and prove that the COAP messages are really short. And in the next episode, we will use our Raspberry Pi as a secure COAPS client and connect it to the IKEA gateway. And in addition, I will show you a hot secret of the IKEA intelligent bulbs. So stay tuned. I hope this video was useful or at least interesting for you. If true, then like. Bye!